Visitors from space. What are meteorites? Have you ever looked up at the night sky and seen a shooting star? It's not actually a star, but a meteor. A meteor is a small piece of space rock that enters the Earth's atmosphere. As it falls, it heats up and glows brightly. Most meteors burn up completely, but sometimes a piece survives and lands on Earth. These are called meteorites. Meteorites are like time capsules from space, holding clues about the early solar system. Meteorites are broadly classified into two main types: stony meteorites and iron meteorites. Stony meteorites are the most common type. They are made up of rock-forming minerals, just like the rocks we find on Earth. But stony meteorites also contain something special: chondrules. Chondrules are tiny, rounded grains that formed in the early solar system before planets existed. They are like little time capsules that preserve information about the conditions in the solar nebula, the cloud of gas and dust from which our solar system formed. Iron meteorites, on the other hand, are much rarer. They are made up mostly of iron and nickel, which are metals. Iron meteorites are incredibly dense and heavy. They come from the cores of asteroids that were once molten, meaning they were so hot that their insides turned to liquid metal. As these asteroids cooled and solidified, the iron and nickel sank to the center, forming a core. By studying the composition of iron meteorites, scientists can learn about the processes that shaped the early solar system. They can also gain insights into the formation of Earth's own core, which is also made up mostly of iron and nickel. So the next time you see a shooting star, remember that it could be a piece of a shattered asteroid, carrying with it the secrets of our solar system's birth. On a cold winter morning in 2013, the world received a dramatic reminder of the power of space rocks. A meteor, larger than a 6-story building, entered the Earth's atmosphere over Chelyabinsk, Russia. The meteor, traveling at incredible speed, created a blinding flash of light that was brighter than the sun. People across the region, from hundreds of miles away, witnessed the spectacular event, but the dazzling display was just the beginning. As the meteor streaked across the sky, it left behind a trail of smoke and dust. Then, the unthinkable happened. The meteor exploded in an airburst, releasing a tremendous amount of energy. The explosion was equivalent to about 440,000 tons of TNT, or roughly 30 times the power of the atomic bomb dropped on Hiroshima. The shockwave from the explosion rippled across the region, shattering windows, damaging buildings, and injuring over 1,000 people. The event caused widespread panic and confusion as people struggled to understand what had just happened. Section 4. Unlocking Cosmic Secrets: What Meteorites Teach Us. The Chelyabinsk meteor event was a stark reminder that Earth is not immune to the dangers of space. But amidst the destruction, there was also a silver lining. The event provided scientists with a wealth of data that has deepened our understanding of meteoroids and their potential impact on our planet. Scientists from around the world flocked to Chelyabinsk to collect fragments of the meteor. These fragments, like pieces of a cosmic jigsaw puzzle, hold valuable clues about the early solar system. By analyzing the composition of these fragments, scientists can learn about the conditions that existed billions of years ago when the solar system was forming. They can also gain insights into the processes that shape asteroids and other celestial bodies. The Chelyabinsk meteor event also spurred advances in our ability to track and monitor potentially hazardous objects in space. Scientists are now using sophisticated telescopes and computer models to identify and track asteroids that could pose a threat to Earth. Section 5. Guardians of Earth, Planetary Defense and Public Awareness. The Chelyabinsk meteor event was a wake-up call, reminding us that we are part of a larger cosmic neighborhood, and that space, while awe-inspiring, can also pose risks. But the event also highlighted the importance of planetary defense, the collective efforts to protect our planet from asteroid impacts. Planetary defense involves a multi-pronged approach. It includes detecting and tracking potentially hazardous asteroids, developing technologies to deflect or disrupt them, and raising public awareness about the importance of preparedness. International cooperation is crucial in this endeavor. By sharing information and resources, nations can work together to protect our planet from this cosmic threat. But planetary defense is not just the responsibility of governments and space agencies. It also requires the participation of the public. By staying informed about the latest discoveries and advancements in planetary defense, we can all play a role in safeguarding our planet for future generations.